Do you have one example?
How do you pronounce that word again?
Eukaryote?
You came up with bacteria.
Are bacteria eukaryotic?
I want to go with sometimes. No?
Nope, they're actually never.
Ooh.
I know. All right, so we can't use bacteria. What about an amoeba? What's an amoeba? It is. You are probably familiar with it from hearing about it going up your nose and eating your brain. You heard of one of those? It's true. Sorry. I know it's one of those things that you wish was an urban legend. No, not an urban legend. If you go swimming in a stagnant, warm lake or pond and you get that water up your nose, there are parasitic amoeba who will eat your brain, and you are correct, they are eukaryotic. Yes.
Wait, that can happen in
Yes.
hot tubs?
No, he said, will it die? Or will you die? Yes, that is a fatal condition.
Not common though, right?
Is it common? Well, not especially, but typically when you guys think of things like parasites, you usually associate it with places that you decide seem unclean, right? Like, oh, clearly, like any place in the tropics, that's where you get parasites. You know, you can get that brain amoeba parasite at your pond on your property up north. Like, that's a here thing. That's a real thing. Those of you who have ever seen the joy of the sinus rinse, the neti pot. I say this because some of you will have seen it as a treatment for sinus infections. Use bottled water, not tap water. You can get that same amoeba from tap water. This is why you take biology. So I'm just trying to save you guys from brain-eating amoeba.
I know it.
That really it is. I mean, it's the most practical application of this knowledge. So we know that an amoeba is a eukaryote. They're typically not multicellular, but they're definitely eukaryotic. How about a mushroom? It's a fungi. It is multicellular. It's too big, absolutely. Way too big to be unicellular. They are multicellular eukaryotes. So the process that we're talking about occurs, mind you, there are 6 kingdoms. You may not know all 6. There are 6 kingdoms of life. Animalia, they're all eukaryotic. Plants, all eukaryotic. Protists are all eukaryotic. And fungi are all eukaryotic. So anything that falls in those 4 kingdoms are all eukaryotic. This particular system of cell division that you're going to learn only applies to those eukaryotic kingdoms. The prokaryotic kingdoms are archaebacteria and eubacteria. Those, completely different system of dividing, which is suspiciously a lot more like photocopying than properly dividing. It's called binary fission. So you told me that this particular version of fission is comprised of phases. Do you remember what they are? All right, we've got 1. We forgot the first one.
Interphase.
Prophase. These all added up make a system or a process called mitosis. Mitosis is the division of the nucleus of any cell. So the reason that mitosis only applies to eukaryotic cells is because, well, only eukaryotes have a nucleus. You can't really divide your nucleus if you don't have one. That makes sense, right? Seems logical. Yes, I think it seems logical. This is where some of you are going to discover that I tend to just take pictures directly out of your book when we talk about them in class. So the question was, do I have to bring my book with me all the time to class? Well, I'm going to reference images from your book. It's helpful on days that you may have vocabulary assignments and things like that. There will be times that I have you and people near you open your books. So I don't know necessarily that you use it every day, provided you and the person at your table work out a system for who's going to bring it when. That's what I would do. Except I was also the type A personality student who would always bring it no matter what my partner said, because never trust the person sitting next to you, right? Look at the person at the table next to you. How many of you are like, yes, I will trust this person? Your current partner. Well, don't worry. Mariah Berryman will be sitting next to you. I assure you, she'll always have her book. Yes, clearly she stole your book. Let's see, which one's the one I want? Okay. This picture you will find in chapter 10 of your book if you do have it with you. You'll notice that this picture takes all of the cell cycle. So if mitosis is the division of the nucleus, that's only one small part of a cell's life, right? Do all cells always have to divide at all times? No. Can you think of any cells in your body that stopped dividing a while ago? Well, at your guys' age, mine, absolutely. They stopped a while ago. How about you guys? Your bone cells?
No.
Some of you are still growing, right? Some of you claim to have not started growing yet. So some of you, your bone cells are still growing. How about that thing dwelling between your ears? Is your guys' brain still growing?
It's developing, not growing.
So most of you guys, your brain has reached full size. It's the process of how it gets used that is still changing. Once your skull reaches full size, your brain has to stop growing because, well, if it doesn't, it's going to quickly outgrow that thing that you carry it in. Agreed? You are not hermit crabs. You can't replace your skull with a larger version when your brain outgrows it. And now I'm worried because only a couple of you are like, yeah, good point. Make it clear you do not get a larger container. So your brain better stop growing so it doesn't outgrow its shell. How about livers? Is your liver still growing? Your heart?
Can't your liver regrow though?
Yeah, it can regenerate.
Mm-hmm. So if it sustains any damage, portions of it, but only small portions of it can regrow. If you're looking for like half, like if you're going to lop off half of someone's liver, that's not going to grow back, but a small portion will. Unfortunately though, if it sustains too much damage, like cirrhosis of the liver, that's not repairable. That's a permanent thing. But if you like bruise it, God knows how you managed to bruise your liver. But if you should happen to bruise it, it will repair itself.
My cousin did hers. She fell at school. Allegedly.
On what?
I don't know. She hit her side and she bruised her liver, but then she went in because she was an alcoholic.
That's probably
She bruised her liver. How old is she? She's like 30.
That's a pertinent piece of information to
Yeah.
that story. It would make her liver more susceptible to damage.
Yeah.
As far as reaching full size, yes. So, like your tongue, it's going to reach full size, right? But something weird happens with our tongue. Because you're constantly eating, it's constantly shedding cells. So those always have to regenerate, just like your skin always has to regenerate. So those things are cells that will never stop dividing. Things that stop dividing are anything that reaches full size and does not easily sustain damage. Organ systems like, oh, I don't know, a kidney, a liver, heart, brain, those things will all stop dividing. So do they ever have a need to go through mitosis? So what are they doing then? If they're not dividing,
They're keeping us alive.
yeah, they're doing their thing, right? Do you suppose doing their thing is an important part of the cell cycle? Okay. This diagram to you will become very important because you'll see something suspiciously almost identical to it on your test on the 30th. Not that I'm pointing anything out to you specifically, but you'll see something that looks almost identical to this on your test on the 30th.
This? This?
Yes, this.
What page were you on?
245. This particular process that you are currently looking at is called the cell cycle. And it includes mitosis, but is also composed of interphase. So, hey, have you seen the word interphase at all today, elsewhere?
Yeah, right there.
Yeah, what'd you write for it?
Give me a second. I said is the period of cell cycle which takes place between each of the divisions.
All right, it's a period of the cell cycle that takes place between each division. Naturally, biologists, when we take a look at the cell cycle, we tend to always start right here. Right there. And then we proceed through the cell cycle. But it's a circle, so we're going to end where we started. Interphase is composed of 3 parts, G1, S, and G2. So that's all of this together. Remember those cells that we said they weren't dividing because they didn't have a need to divide, but they're keeping us alive, doing their thing? Those cells are in interphase. G1 is what we call gap 1. And that's any cell that's kind of doing what it does. So it's a liver cell being a liver cell, or a brain cell being a brain cell. They're performing their daily tasks. They are performing their daily tasks. In S phase, that's when DNA is going to duplicate. DNA duplicates during the S phase. Hey, what do you suppose it means if somebody says something twice? I said that the S phase is synthesis, which is when DNA duplicates. You guys recognize that DNA is like the blueprints of an architect. It's the set of instructions that gives a cell like every single one of its important life functions and directions for performing those functions. So without the directions, a cell would be aimless. It wouldn't know what to do. It would be like a general contractor not receiving blueprints. The contractor's just going to stand there and nothing will be built. So if you're going to have a cell divide in half, it had better have enough DNA to give the 2 new cells a full complement of DNA. The process of ensuring that that's going to happen happens here during the S phase. G2 is gap 2. Gap 2 is where the cell is going to make sure it has all the extra stuff that's not DNA. What kinds of things are in cells that are not DNA?
Organelles.
All your organelles. Mitochondria. Sound like one that's vaguely familiar? Please say yes. Okay, good. How about ribosome? Endoplasmic reticulum. Both rough and smooth. Can you think of another one? Lysosomes? I was giving you a lifeline.
Yeah, I thought you were talking about
Oh, no, I was, but.
cytoplasm.
Cytoplasm.
Or cyto,
So we're going to hold on to that thought, the cytoplasm thought, because we're going to need more of it, aren't we? But do you think it's going to be here where it grows?
no.
How about a Golgi apparatus?
Yeah, that's.
I know that was your second choice.
Yeah, of course.
It seems logical. I took you for the kind of guy who's like, yeah, the Golgi is my favorite. That's good.
It is.
All of those things are going to duplicate at G2, at gap 2. That leaves us with this part that's left, mitosis. So gap 1, S phase, and gap 2, S meaning synthesis, which I think I vaguely said, but I want to make sure. All those add up to being a cell being a cell. It's interphase. It's when the cell does what the cell does. Mitosis is when the nucleus divides. Now, I really dislike where it says cell division here because the only part of it that's really cell division is cytokinesis. Prophase, metaphase, anaphase, and telophase, those are all nuclear division, the division of the nucleus. Now, you all told me PMAT, right? That was the order you gave it to me. Well, okay, actually you started with anaphase, then you did telophase, then you did metaphase, then you did prophase. But you gave me all those phases. That means that you know something about them, right? I like your very honest answer, no. How many of you are like, no, but I know those words? Okay, I'll take that. How many of you are like, yes, I am so mad confident in my mitosis skills that I'm just going to get up and walk out? No? Take a moment with your partner to write a short definition of prophase, metaphase, anaphase, and telophase. Talk through it with your partner. Don't just like stare at them. You, my friend, get the dubious distinction of joining the group in front of you since you are lacking partner today. Hey, it's on the next page. No way.